Today is 28th August 2020 and we are going to discuss about the details of the equipments that are used in TIG. Whenever you start TIG, the most important thing which comes in mind, that is the welding torch. So we will discuss with welding torch first. It is a special type of uh, torch which having a collet and a non-consumable tungsten electrode fixed on the collet. So non-consumable tungsten electrode is fixed on the collet. I think you all know what is collet. The collet is a type of chuck which holds a rod. Next, this should be either water cooled or air cooled. In case of high current required in the welding, then it should be water cooled. Now, the power source uh, provides the current with help of a cable, and that cable is connected to the electrode. Whenever the current goes beyond 150 ampere, so beyond 150 ampere, water cooling is essential. Okay. Now, the property of tip varies depending on the power supply. First of all, let me draw a diagram. I'm trying to do it. So this is the water jacket, and this is water supply. This is gas supply. So these gases comes out and forms the shield to protect from atmospheric contamination, and the water comes out of here. So did you understand the points? And this is the collet, this is metallic, and this is connected to the power source, and this is kept negative. Reverse polarity is used in most of the cases. Maximum cases reverse polarity used. Now when the tip of the electrode, when the electrode is positive, then the tip will remain like this, if it is the diameter of the tip, diameter of the rod, then the taper would be 2D. When so tape, or you can call it taper, is 2 into dia. Now these happen when electrode negative, electrode negative and job positive. I'm writing it up. Electrode, sorry. This is electrode. This is negative. So electrons coming out from the tip of the electrode is impinging on the job and thus providing more penetration. Now, if we use a straight polarity, that means electrode positive, then the electrode tip becomes a shape like this because the heat generated on the electrode tip is higher and the electron flows like this way. So as a result, this tip of the electrode gets softened up and might be produce droplets of tungsten if high current
Sir,
is used. Yes,
sir, excuse sir. I'm telling that. Can you please tell the last word of the first sentence? Non-consumable tungsten electrodes is fixed on the.
collet. Collet is a mechanism to hold a rod type of things, cylindrical rod.
Okay, sir. Thank you.
Collet তোমরা পড়োনি লেদ পড়ার সময়?
Oh, collet. COLLET.
Yes.
Okay.
So this happens when electrode kept positive. Now if we use alternating current, then also heat generated on the tip of the electrode is higher than the electrode negative but less than the electrode positive, and this tip soften up and looks like this when it is AC current is used, because heat generation is 50-50, 50 on the 50% on the workpiece and 50% on the electrode. Now for this case, to avoid the softening up of the tungsten, we use thoriated tungsten or zirconated tungsten. And when tungsten liquefies, it is attacked by the nitrogen. That's why also the thoriated tungsten or zirconated tungsten is used. And these both can resist high temperature. Now, the filler metals, if required, provided separately, and that filler rods up to 4.5 mm dia is used. अरे यार, sorry, somebody is calling. Give me a second. हाँ सर. হুম, 10 মনে হয় স্যার, আমি ক্লাসে আছি, বেরিয়ে ফোন করছি. হুম. Okay, is it visible now? Is it visible now?
এই যে ডায়াগ্রামটা একটু দেখাতে পারলে ভালো হয়। পুরোটা করা হয়নি অ্যাকচুয়ালি। থ্যাংক ইউ স্যার।
Okay. So filler rods that can be used up to 4.5 mm dia. Now we use a power source. So power source, AC and DC, both type of power source are used. But we prefer DC RP or AC. Mostly this DC RP is used. Now DC RP or AC used when we are welding mild steel, aluminium, magnesium, and their alloys. What is the profit then? This reverse polarity helps to remove the surface oxide film on aluminium and magnesium, and we require high frequency power supply to keep the arc ignited. If the frequency of the power supply becomes lower, then the arc will not be stable. Okay, here the current properties of the power supply is drooping type or constant current type. Because it is mostly used on manual operations. Whenever automation requires, we mostly go for DC. Sorry, we go for MIG. And TIG has some special purpose used only because its speed productivity is less than MIG. We will discuss. Now, DC is preferred over AC for welding. DC is preferred DC is preferred over AC for welding stainless steel, for welding nickel, copper, and their alloys. A power source, normal regular case in GTAW, power source rated from 3 to 200 ampere or 5 to 300 ampere with voltage range 10 to 35 volt only, and with 60% duty cycle. That means if the machine kept on for 1 hour, it can work only 36 minutes. So one type is 3 to 200 ampere, second one is 5 to 300 ampere, and working voltage remains 10 to 35 volt, which is very less kept. Now for higher value of voltage, then the arc will be aggressive and the welding bed will be brittle. Spatter will occur. So that's why the voltage kept lesser. Now the inert gases used in this method is argon, helium, argon plus helium mixture, argon plus O2 mixture, argon hydrogen mixture. Now these mixtures are for particular uses. Pressure regulators and flow meters to be used to step down the pressure from cylinder. So pressure regulator and flow meter is must, and in cylinder pressure is generally kept 120 to 140 or say 150 kg per centimeter square, and when we work we need to reduce it to about 20 kg per centimeter square, 20-25 kg per centimeter square. Now we'll discuss over the advantages of TIG, tungsten inert gas welding, which is also called GTAW, gas tungsten arc welding. Advantages are this is very suitable for high quality welding for thin materials. As most of the cases we do not require filler material, so we use it on thin materials normally. Deeper penetration can be achieved no flax is used, so no chance of flax entrapment. This process can be seen through welding goggles, so better control is achieved by the welder. It is also very suitable for non-ferrous metals and stainless steels. Welding stainless steel is quite difficult because its melting temperature is quite high, and uh, we need a very requirement, very regulating environment. With TIG you can do that. You can apply high temperature where it is required. But if you use always high temperature, then it will be, oxidized. So that's the huge problem. But with TIG, SS can be welded. Now TIG is suitable in all positions. Suppose whenever we are having a overhead welding, so in such case, the MIG, in MIG or in other MMAW, this what happens, the material gets transferred, the liquid metal gets transferred in droplet method in most of the cases, and in such problem, it is very difficult to weld in overhead position. But TIG is, okay with all the positions. Now it has some limitations too. Limitations are, it is slower than MIG or MMAW, though these are similar. Now, if tungsten is heated, if it is transferred to molten metal pool, it creates the joint very brittle, as tungsten is very hard and brittle material. I mean, tungsten is not brittle material, but when it makes compound with other materials like oxygen and all, then it becomes, the joint becomes, hard and brittle when the tungsten get included. Tungsten is hard, quite hard, but not brittle. But when it produces alloys with making chemical reactions, then the joint becomes brittle. Now, the equipments are more costly compared to the other processes, because on the same controller we need a, a gas flow control system, we need a current control system. That's why the price of it becomes little higher. uh, MIG price also is higher, tungsten is little more higher, and skilled operator is required, otherwise you cannot produce good welding bead. So skilled or trained operator is required, as because it is mostly a manual process. MIG is semi-automatic process, so that's why the skill level required for MIG is lesser than TIG. Now the applications are, to join aluminium, magnesium, copper, nickel, and their alloys, stainless steel, inconel, zirconium, and titanium. Welding these materials, this TIG is very suitable. Number two, welding sheet metal and thinner section. Number three, precision welding can be achieved. and it can help in atomic energy equipment. It can be used in aircraft industry and also instrument industries. Profit is as because this is precision welding, that means the heat affected zone is very less, so the change of mechanical properties beside the heat affected zone is minimal, and heat affected zone is also very less, so that's why it is used with very good precision. Now there are a few variations in TIG. Variations are, there are pulsed current, GTAW, sorry, gas, tungsten arc, spot welding. Basically, spot welding is a type of resistance welding, but whenever you require welding only spots but not throughout the joint, you need only spots, then also you can use it. You can use manually programmed GTAW stations, and you can use twin electrode GTAW also. Give me a minute. Okay, so now we look like how the pulsed DC current looks. Now this section is the pulsed current time, and this this section is basically the uh, off time, and these are the pulse welding current value. Now if we look for AC, it is just like this. We all know how AC current look like, but this is pulsed DC, this is normal AC, and this is, oh god, let me change my pen, just a minute. This is called pulsed AC. So along this portion, it is achieving higher values, and this is basically off time. Now as per requirement, you can control it through the power source controlling system. Now, when this pulsed current is provided, it is about 1.5 to 2 times than the normal steady state current when used for the same workpiece. Okay, so this pulsed current value is 1.5 to 2 times than normal value current. Now there is a very important question, which is the comparison between TIG and MIG. TIG, MIG. Whenever the comparison comes, you need to divide it into two columns and then you have to go on. So for TIG, it is non-consumable electrode. However, if you do not use water, if you do not uh, let it cool, you are using continuously at a very high current value, then the TIG electrode also get consumed. So you have to take care of that. And if the TIG electrode is consumed, then it produce very hard and brittle joint. Now MIG, the filler wire, in some cases copper coated to save the wire from uh, atmospheric hazard like rusting off. This type of problems occur. So to protect the wire, it is made copper coated in some cases. So the filler wire is used as electrode, which is consumable. Number two, filler rod may not be needed. Number two, fillers are always needed. Number three, TIG is slower process, less productivity. This is faster process, so higher productivity. It requires TIG requires skilled labor or welder, right? Welder, because labor is lower class than welder, so you have to use the welder term. It seems better. It requires not much skill is required because it is semi-automatic process. You just fit it up and watch over the process. Number five, penetration is not so deep as MIG, and penetration in MIG is higher or deeper. Number six, this may be water cooled, and this welding gun may not be water cooled. Number seven, it is not recommended above 6 mm thickness Here in MIG there is no such condition. Number 8, if filler rod uses, both hands will be engaged.
If the rod.
If filler rod is used, then both hands will be engaged. And
Okay, sir. Thank you.
in MIG, only one hand is enough for welding the job, just to control the movement of the workpiece, or the if workpiece is fixed, then the movement of the electrode gun is required, MIG gun is required. So one hand is enough for working. Okay, so now with this we will end up the TIG, and we go forward on our next topic. Should we start our next topic today?
The filler rod.
If filler rod is used, then both hand will be engaged, because in one hand you are holding the TIG gun, in the other hand you are holding the filler rod. But in MIG, the
Okay, sir.
normally workpiece is fixed, and you need to control only the electrode gun, MIG gun. So it is easier. You can work with one hand. Okay, our next topic is resistance welding. Here, resistance welding is a type of pressure welding process. We first squeeze the workpieces between two electrodes, then we apply very high value current for a very low time, and because of the resistance in the workpiece, uh, heat is generated at the surfaces of the between these two workpiece surfaces, and a little metal get get melted and forms a nugget upon solidification. So we use the formula to produce heat is equal to I square RT, where T is time, R is the resistance, and I is the current. Now R is basically combination of uh, two electrodes and the resistance of the workpiece together. Now initially, in a very simple way, we have two electrode like this, and we squeeze the job between these two electrode and pass very high value current. As a result, between the workpiece in the connecting surface, very small molten metal is produced, and upon solidification they produce a nugget and forms the joint. It's better we stop today. Only 4-5 minutes left, so we'll stop today, and on the next class we'll continue on resistance welding.
Sir, can you show me the previous page, sir, last line, sir?